Rivers are like the veins of the earth, branching out and reconnecting, carrying the lifeblood that is water all around the globe. Scientists have been fascinated by freshwater environments for ages, starting with Francois Alphonse Farel, the father of limnology, or the study of freshwater. Split up into two categories: the study of lentic systems, bodies of still water like lakes and ponds, and the study of lotic systems, moving bodies of water like rivers. This is what we'll be focusing on. Rivers provide for the world in many unique ways, such as being a source of clean water for drinking, watering crops, and a transportation pathway used both by humans on boats and by migratory fish, swimming either inland or out to the ocean. These migratory fish are an important food source to many animals, and may either be anadromous, meaning they were born in freshwater, moved to saltwater, then returned to freshwater to spawn, such as salmon, or they may be catadromous, meaning they start in saltwater, move to freshwater, then return to saltwater to spawn, such as American eels. But there's a major part of our world that stops the flow and prevents our rivers from doing their jobs: dams. Dams are created to hold back water, often to prevent flooding. The water the dams hold back pools together to form a reservoir, and the water stored here is often used for drinking, farming, and industrial uses. The water flowing through the dam is also used to generate power. And it's true that these are all important purposes, but it's equally important to acknowledge that dams can cause harm. Looking back to the discussion on migratory fish, how can these fish get to where they need to in order to spawn if the rivers they're so used to navigating are blocked or altered? Dams also impact water quality. Slow moving reservoirs can heat up, causing temperature to fluctuate in ways sensitive species can't adapt to. This warmer water can also cause algal blooms, which leads to oxygen loss. Dams also cause erosion. Since much of the sediment rivers carry gets trapped in the reservoir, as the water is allowed to keep flowing at a controlled rate, those sediments are left behind, meaning the water is only able to pick up sediment downstream, not place any down to balance out the travel of sediment. An extreme example of the harm dams can bring is the Three Gorges Dam, the largest in the world. It is located on the Yangtze River in China. In 2008, a massive earthquake was caused by the pressure the reservoir was putting on the two major vaults the dam was built on. This earthquake killed 80,000 people. China was also experiencing droughts downstream, lake networks becoming separated from one another, and increased waterborne disease and pollution as many factories, landfills, and mines were flooded and submerged beneath the water. With all of this in mind, what can we do to help? Well, we can't just get rid of every dam in the world. Our society is far too dependent on them. So let's compromise. Some dams are well established and important. Those need to stay, but less essential dams can be taken down, allowing some rivers to flow freely. This is exactly what the Penobscot River Restoration Project did, taking down two dams and increasing power generation from others to compensate. This project worked out beautifully, opening 2,000 miles of river habitat to many fish. This shows us that while dams aren't going away, we can still minimize their environmental effects and get the best of both worlds.